Hi everyone. Is it connecting okay? Is the sound working? Now let me go back to the first page. Let me know if the sound is working. Yep, it should be live now. Just going back to I was just laying it all out. There we go. I'm doing well, thanks. How are you guys doing? How are you feeling for tomorrow? Are you ready? To the person who's asked about foundation, I don't this year. No, I'm sorry, I don't do foundations this year. Unfortunately, I might kind of look into it for next year, but I know that's not very helpful for you. I'm assuming you're doing it this year. The first kind of maybe 4, 5, 6 questions of the higher paper are always, at least for Edexcel I know, are always the last 4, 5, 6 questions on the foundation paper though. So there is like a tiny bit of overlap, but not that that's, massively helpful, I would imagine. All right. Yeah, I would have said the same. I guess it depends on the person, but I genuinely think it's easier to pass a higher tier paper than it is a foundation because you have because the grade boundary is so much lower, so you don't even have to, I wouldn't even worry about learning the whole content, just learn enough to give you like 20-30% and then you would pass. But not that that's very helpful now. I don't think I'll let you swap at the last minute. Yeah, you're right. I think you need about 20% to maybe 25 if you're being safe, maybe 30% to pass a higher tier paper, which is basically just one of the papers. The other two you might just, like, technically you could answer one of them completely correct and then just not answer the other two and get a pass. Whereas foundation, I think you have to get like 55%, 60% to get a pass. I also personally find foundation a bit harder to understand, the wording of it, because I feel like they use a lot more words rather than obviously maths. But then that depends on the person as well. All right, guys, we'll make a start. So as you can see, this is the November 2018 paper 1 higher tier paper from Edexcel that we'll be going through from the start. So last preparation for tomorrow's exam. I honestly wouldn't know how hard it would be. I really don't know. I couldn't guess, to be honest. Will there be histograms? I hope not. If I were to guess on histograms coming up, I would say it's unlikely because I think most of the time it comes up in paper 2 or paper 3. Last year, I think it came up on paper 1, so I don't know if they would do that again this year. Again, that's not, I don't know. They might do. Who knows what they're actually going to do? I think I would say histograms unlikely, but not impossible. Yeah, histograms. Yeah, fair. It's not a nice topic. Okay. Videos, if anyone's in year 10 right now, I will be carrying on next year. I won't be doing lives like this the whole way through the year, but I will still be uploading videos, and then when it comes to exam season, I'll start doing lives again. So yeah, for next year. How much do you need on each paper for 5 or 6? I have got the average grade boundaries. Let me grab those. It's not as high as you think, to be honest. Probably like 30-40%. Let me just check though. Grade boundaries. Okay, this is just me speaking for Edexcel. You can see it here. I don't have the values for AQA or anything, but if you have a look here, this is the average for the last few years. I haven't included 2024 because I don't think they've uploaded that yet. But for 2023 and up, until 2017, on average, 4 is 18%, on average 5 is 30%, 6 is 43%. But again, this could vary, right? So I'd probably round those up. Maybe to be safe, let's say a 5 is 40%, let's say a 6 is 50%. Do you know what I mean? Like round it up just to be safe. Yeah. For a 5, it says 24 marks, obviously out of each paper, right? But as you can see, I've got kind of the averages here, so they do change. So a 5 over here was 33%, and then the year before was 30%, and then 27%, and it does vary, right? 33% again, 30% again, 33%, 28%. It's all over the place, but just so you got an average. Yeah. So yeah, not as high as you'd think is all I'd say about that. You've got May paper 1 2023. I have gone through that, I think, in one of my other lives. It'll be uploaded on the channel if you want to have a look at that. Let me see which one it was. I mean, with circle theorems, you can use different methods to get to the same. As long as you've got the same answer, then it's fine. I don't know if you ended up with a different answer. Then obviously that I would assume they would say it's wrong if you've got a different answer. But if you got the same answer but did it a different method, I would assume it was fine. 2023. Yeah, give me 1 second, guys. This one. Why this is an alternate segment theorem. Alternate segment theorem, I know it's a triangle touching here, but it has to be touching all corners. I don't know if that's enough to kind of explain. It's not like it's not also alternate segment theorem unless you were to draw your own lines. But it has to touch the circumference. So you see how this triangle, okay, yeah, it does touch the circumference here, but it doesn't, like, it touches the center, it doesn't touch. BAD is not 64 because they're not parallel lines, or they're not it's not alternate what's the other one, angles in the same segment, because again they have to touch the circumference. This one here, the center doesn't touch the circumference. So this one here would actually be, if you wanted to use 64 to work out BAD, is angle at the center is double the angle at the circumference. Yeah, exactly. That's the one that I would use. Imagine if you picked up angle A and dragged it all the way over here, you'd get that kind of arrow. So this one should be 32. Yeah. So it's not alternate segment theorem because it doesn't touch this, like all the points have to touch the circumference, only one of them do. It's also not angles in the same segment for basically the same reason. It would have to have all of the corners would have to touch the circumference. So yeah, okay, perfect. All right, guys, we're going to make a start. If you want to know any topics that I'm predicting for tomorrow, I've got a video that I uploaded called non-calculated, like most common, this is for Edexcel again, most common or most repeated non-calculator Edexcel questions, and at the start of that video there's like a list. I can link it, but we'll make a start on this paper. Let me just link it in the comments and then we'll make a start. Here's the video. If you look at the start of that video, I know it's quite a long video, but if you just look at the intro, I've got a list of what I think is like the most common topics. Okay, right, so turn the volume down on that. Okay, we've obviously got indices, index laws, negative indices, all of that kind of thing, very common. So work out the value of 3 to the power 7 times 3 to the power minus 2 over 3 to the power of 3 cubed. When it says value, they want the actual number. But obviously I'm not going to work them out individually, right? I'm not going to work out 3 to the power of 7. I'm not going to work out, do you know what I mean, all of them individually. I'm going to simplify it first by using my index laws, and then at the end, then I'm going to find the value, okay? So obviously when we're multiplying, we're actually adding the powers. So 7 plus minus 2 would be to the power of 5, okay? over 3. And then when we divide, we're obviously subtracting, so that would be 3 squared. But they have asked for the value, so then now I'm going to work out what 3 squared is. Do you see how it's much more simplified? Which is 9. Okay. Yeah, 3 to the power 5, yeah. Okay, so just check, have they asked for the value? Have they asked me to just simplify it? Because that's 2 different questions, isn't it? In this one, they want to see that you've written the number 9. Okay, question 2, just some kind of really simple kind of basic algebra, basically. So work out a value of v when we've been given these values here. So u is 12, a is -3, just be careful of that, and s is 18, so we're just going to sub them in. And don't forget at the end you do need to square root. So u squared, 12 squared, plus 2 times -3 times 18. So we've got 144. That's, you can multiply that however you want, I guess. Whichever order you prefer to multiply it in. You could do 2 times 3, which is 6, and then times it by 18, or you could multiply it in a different order. Whatever order you want to do it in is up to you. When you multiply, you can multiply in any order. Either way, you should get not just 108, but minus 108. Don't forget that there is a negative there. So when I subtract it, because they're going to make me square root, I'm assuming I should get a square number. Yeah. Now, again, don't forget to square root, though. So when I square root that, now this is where they've said a value of v, because technically there are 2 answers. Technically, you probably wouldn't think of the other answer really, but technically there are 2 answers. When you square root anything, you get plus or minus. So I would have just written 6. If you wrote down -6, they would also give you the mark for that, as long as you write one of those 2 things. That's fine. Obviously, they won't make you square root anything that isn't already a square number. So if you didn't get a square number here, 36, then you double check your working, because something's probably gone wrong. Okay. All right. Part B. I'm going to scroll down. Make S the subject of this formula, so the same formula. I think a lot of people get distracted because they feel like they need to start square rooting things, but we don't, because we're just focusing on getting the S. So I always start by, if there's anything to add or subtract, I try and do that first. So I would take away the u squared. Just move it. Don't need to square root it, just literally move the whole thing. And now, I want to obviously get rid of this bit. I would just divide them together, just as a piece. So divide by 2a. Okay, so don't start square rooting anything unless the letter you want is obviously one of these, which it wasn't. Don't need to square root anything. So v squared minus u squared over 2a is your answer. Yeah, exactly, that's your answer. Okay, nice 4 marks, just some kind of straightforward algebra stuff there. Okay, now there's normally some kind of, I feel like, worded question in the first 5 questions where it could be percentages, ratios, fractions, could be a bit of both. So here we've got a bonus of £2,100 is shared by 10 people who work in a company. 40% of the bonus is shared equally between 3 managers, and then the rest of the bonus is shared equally between 7 salesmen. One of the salesmen says, if the bonus is shared equally by all 10 people, I will get 25% more money. Is he correct? So what we want to do is do the 2 options, right? So the first option, we want to basically work out, there's loads of different ways to do these worded ones, depends which order you do it in. I'm going to do it this way. If 40% of the bonus is for 3 managers, we only want to focus on the salesman, right? So 7 salesmen would share 60%, so that's probably what I would do. I would work out 60%. Now you can just obviously work out 40% and then subtract it, that's also fine. So whatever method you've done, as long as we get the same answer. So I would probably work out 60%, so obviously I'd have to divide by 10 to get 10%. And then I would times by 6. You could obviously times by 4 if you want 40%. That's obviously 210 is 10%, isn't it? So then 6 times 210. We've got 6 times 200, 1,200, 6 times 10, 1,260. You can obviously use column multiplication if you want. So that's my 60%. Now, that is shared. So I found 60% because if we come back here, do you see how they said 40% was shared between the managers? But I don't really care about the managers, do I? Because they're asking me about the salesman. So if 40% is shared between the managers, then the rest of it is 60%, isn't it? Which is then shared between the salesmen. So that's why I'm finding 60%. As I said, you can, if you want, obviously, if it makes more sense to you, work out the 40% for the managers and then subtract it to then get what's left, which is for the salesman. I just kind of did it more directly. It's up to you, whichever method you want to do, as long as you end up with the same number. Then it shouldn't matter. Now, obviously, I want to then work out between 7 people, don't I? I need to divide that. So I'd probably use bus stop myself. You can divide it however you want. Personally, I would rather use the bus stop. It's fine, as long as you get the same answer, it's fine. It doesn't matter what method you use. So obviously 7 doesn't go into 1, so I'm going to straight look at the 12. 7 into 12 is once with a remainder of 5, so 56. 7 goes into 56 8 times, no remainder. So yeah, as you've said, 180. So in the original case, they get 180 each, don't they? Originally. Then I'm going to look at the other option, which is what they've suggested. If the bonus is shared equally between all 10 people, so I'm going to just share it equally. Well, technically we already worked that out, didn't we? So it's either that or the 210, isn't it? In his other version. Yeah, so then we want to work out a percentage exactly. So again, there's different ways to do this. The way that I would do it is I would work out what the actual percentage is, like the percentage change. Some people would rather just work out 25% of 180 and add it on and compare the pounds. That's 2 different ways to do it. I prefer to just work out what percentage this is, especially because they've chosen quite nice numbers. So percentage change, because we're looking at the difference, isn't it? He said, I will get 25% more money. So we're looking at kind of an increase. So the change, I'd have to work out the difference though. Do you see how the difference is £30? And then I would divide it by the original. So the original is the 180. That's what originally happened. This is the formula that I would do. Now that gives me 30 over 180 or 3 over 18 times 100. You can knock off the zeros. 3 over 18, which is 1/6. I mean, this is where you might prefer not to do that because the decimal is going to be a decimal answer. You might prefer not to do that. You might prefer to do it the other way. Work out 25% and add it on. That's fine. I think when I worked it out, I think I did bus stop again, and I got basically like 16.6 recurring percent. So not a great decimal, but it is possible to work it out. So I got this. So then I personally would be comparing 16% with 25%, and I would say, is he correct? Well, no. You might, I'll show you the other way. Move this across. The other way is that from here you go, okay, what is 25% of 180? So you can either divide by 5 or divide by 10. Obviously 10% of 180 would be 18, 20% would be double that, which is 36. Add a 5%. 5% is 9. Do you know what I mean? Like you could add that up. What does that give me? £45? And then add it on. So 180 plus 45 is 225. And then you'd compare the pounds. You go, do you see what I mean? You'd say, oh, well, if I got 25% more, that's way more than I actually am getting. So again, he's still wrong. So it's kind of these 2 options. Whichever of that makes more sense to you. Obviously, the answer should be no. Compound interest, I think it's very, very, very unlikely because it is normally a really complicated formula, decimals, all of that. Percentages generally, yeah. Compound interest, I think, is normally paper 2. Obviously, it could be paper 3, but I've seen it a lot in paper 2. So I don't think it would. You do get the formula on your sheet, though, just in case. But I think it's unlikely because it's normally loads of decimals, isn't it? So if it did come up, it'd be like a really straightforward like set of numbers, you know what I mean? Probably only like 1 or 2, well, not even 1 year, but like 2 years or so. That one's quite nice. You get 5 marks. Yes, exactly. You can get the mark for saying no because 210 is obviously not the same as 225. Yeah, that was the second option I was giving you. Yeah. That's fine. So it's up to you which way you want to do it. Obviously, this one's more complicated, I guess, because of the numbers. That one is maybe slightly easier for the numbers. 3D trig, maybe paper 3. I mean, obviously, it could come up on paper 2 or paper 3. It could come up on paper 1, Obviously, if it did come up on paper 1, it would be that they would use, you know, the trig values that you know. So 30 degrees, 45 degrees, 60 degrees, like it would be something like that. Again, they would have to choose numbers that were really straightforward if it came up on paper 1. I don't think it's impossible. I think it's unlikely, but it's not impossible. Nothing's impossible, really. Yeah, I think mean comes up quite a lot on paper 1, different types of mean and reversing the mean. Yeah, I think that comes up quite a lot on paper 1. Yeah, I think you're right. Some version of mean. Yeah, there are trends. It doesn't mean that anything is set in stone, though, so don't kind of rely on those. Okay, question 4. This one is a very specific topic, actually. So it would take 120 minutes to fill a swimming pool using water from 5 taps. How many minutes will it take to fill the pool if only 3 of the taps are used? This one has a different context every time, but the topic is the same. I call this is basically inverse proportion, isn't it? The logic is inverse proportion. So you have to think of it as the opposite way to how you might naturally want to work it out. Think about it. If I have fewer taps, it's going to take me longer to fill up the same pool. It's going to take more minutes. Do you see how that's an inverse? So what we want to do, I normally work out how much, you don't have to lay it out like this, but I tend to work out how long would it take for 1 tap. Now, naturally, I think you want to divide by 5, don't you? Because you go, well, yeah, well, 5 taps is this, so 1 tap is divide by 5. It's not, because it's the opposite, isn't it? It's inverse. So it's going to take 5 times as long. If I only have 1 tap, it's going to take much longer. So yeah, you want to multiply. So normally to times by 5, well, you could obviously do 12 times 5, or I just times by 10 and then half it. So you should get 600. So it takes 600 minutes for 1 tap, and then I work out what actually they wanted. So they said 3 taps. So now I'm going to divide by 3. So it's like the opposite. I feel like naturally you want to divide first and then multiply, but it's not. It's the opposite. So that should give you 200. Obviously your answer should be longer than the original, because if I've got fewer taps, it's going to take me longer. You should get something bigger than 120. So it's a nice question if you can recognize, obviously the context changes. Sometimes it's like painters painting something, sometimes it's builders. You know what I mean? Like it's all that kind of same kind of context. And then part B, quite a common question here. State one assumption you made working out your answer to part A. This is always the same, but relate it if you can to the context. The assumption is that I made the assumption that all of the taps, in this case, how would you word it? That the water flows out of the taps at the same rate. Do you know what I mean? Like I don't have a bigger tap on one of them. Like they're all the exact same tap, and therefore the rate of flow of water, or whatever you want to say, the speed of the water is the same. That's what I would say. Yes, this type of question is always reverse proportion, exactly. Yeah, the taps worked at the same rate, that would be fine. Taps flow at the same rate, any kind of version of that, and you know, they'll give loads of options. So, yeah, I don't know, taps flowed at the same rate. You have to relate it to the context. Did I spell flowed? That looks wrong for some reason. At the same rate, I guess I've never written the word down before. Yeah, some version of that is fine. Yeah. Okay, so I think that's quite a nice question if you can recognize it. It's 3 marks. Okay, I feel like there's a lot of speed, distance, time in paper 1, but then I looked through the paper 2s yesterday and there was also a lot of speed, distance, time in paper 2. So it could be either. But we've got here, a plane travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. Now, as you can imagine, this one has loads of different ways to work it out. Again, as long as you get the same answer. It does also say estimate, right? Obviously, estimate. So you can round the numbers if you want. And they do have a range of possible answers, like kind of like a small range. So you might do it differently to how I did it. There's loads of different ways. It's up to you. I think I was thinking you could, you know, because we need to do some kind of conversion, but also we need to do speed, distance, time. You know, it depends what order you did it in. I always just like to get out my formula triangle, speed, distance, time. In this case, it says work out the estimate of the number of seconds. So that's time, isn't it? So I'm doing distance divided by the speed. So I know that the distance is 1 mile and the speed is this. So I'm probably going to round that to 200 personally. I would probably round that because they said estimate. So technically it's 1 over 200, isn't it? However, the answer to that, well, I guess 1 over 200 is an answer, is hours, isn't it? That's how long That's how much time it would take in hours, because it was speed was per hour. Then what we have to do is go, well, they wanted seconds. So how do I change from hours to seconds? And I just go, well, how many minutes are in an hour? 60 times by 60. How many seconds are in a minute? 60 times by 60 again. You might have already multiplied by, what's that, 3,600? Fine. And then I would work that out. Whatever version of working out you did is fine, as long as we get something at the end that's very similar. So what's that? That gave me, I think I used fractions, that on top, 200. And then do you see, oh yeah, that's much easier. You can just knock off the zeros, can't you? And then 36 over 2. I got 18. They've said as long as you get something between 16 and 20, that's fine. Because obviously you might round it differently to how I've rounded it. So as long as it's between 16 and 20, then that's fine. I got 18. And again, as I said, if you worked it out in a different order, also fine, as long as you got the same answer. Now there was a part B. Is your answer to part A an underestimate or an overestimate? So that depends on how we rounded it. Think about it. So I personally, you might have done something different. I rounded the 200 down. However, how does that affect my answer? Why is it times by 60? Because the way that I think about it is because the number of hours is always less than the number of minutes. Like if you think about it, 1 hour is 60 minutes. That's a lot more minutes, isn't it? So I know my answer has to get bigger. So I times it by 60. That's the logic that I use. If I was going from minutes to hours, then that's when I would divide. If I was going the opposite direction, or seconds to hours, I would divide by 60, because the number of hours is a smaller number, isn't it? In terms of like 1 hour. I know obviously the time is the same, but you did, oh, did you divide it the wrong way around? Did you do like 200 divided by 1? And then, is that what you got? No. It wouldn't be that. I think you've gone the wrong way. But also they've not asked for the speed. They've just asked for time, haven't they? I think you've probably done it the wrong way around. Because you see how it's distance divided by time? The distance was 1 mile. The speed was effectively 200. So I divided it that way, based on the speed, distance, time formula. So yeah, I would imagine it's just that. I think you probably did 200 divided by 1 instead of 1 divided by 200. I think that's probably the only thing. Yeah, so overestimate or underestimate. Now I did round down the speed. And then, but then you've got to figure out kind of what you did in your calculation. Like how would that affect it? Because we're dividing, so it's kind of more complicated, isn't it? So because I divided by a smaller number, yeah, I rounded the 213 to make 200. Because I rounded that down, but then I divided by it, if you think about it, I divided by a smaller number. So my answer here that I got, obviously if you put that as a decimal, my answer was a bigger answer. If you divide by a smaller number, you get a bigger answer, don't you? So that would be an overestimate. An overestimate. Also think about it, if I rounded the speed down, then surely it would take less time, wouldn't it? So it's an overestimate. Over, I can spell that, would be helpful. Estimate. And you have to obviously give a reason. I just said as because the speed is rounded down. I think that's enough. Just say what you rounded and how you rounded it down. That's what I said. The equation of a circle could definitely come up. That one could come up on any of them, really, couldn't it? Because it's just algebra. So I don't know how likely it is, but yeah, it definitely could. You rounded to the nearest integer. Well, that's what I also did, didn't I? As in, originally I rounded it to 200. As long as you got something between 16 and 20, then you can say that it was fine. Yeah, as long as you got something between 16 and 20. I got bang on in the middle. You might have got close to 16, close to 20. That's fine. Well, I don't know if it generally, it depends on your formula as well, because I rounded down, but because it was a divide kind of formula, it meant it was an overestimate. If I rounded down, but let's say my calculation was multiplying, just multiplying, then it would be an underestimate, wouldn't it? So it depends kind of more so on your formula, like what did you actually do, if that makes sense. The same with like upper and lower bounds, it kind of depends, doesn't it, on if you're dividing or if you're adding or subtracting or multiplying as to which combination you use. Yeah, I think straight lines is quite likely to come up, for sure. Some kind of perpendicular lines, maybe with coordinates, as you said. You said, can you get the mark for B without... Oh, so if you got the mark, if you didn't get A right, can you get B? Hang on, let me move this. Where's my mark scheme that I had? Let me check the mark scheme. Question 5, this is. Dependent on the correct use. I don't know. It doesn't really specify. I think you might have to get it A right. Because also if you got part A wrong, then maybe your answer would be wrong anyway. Your over or underestimate, I'd imagine. Yeah. I think you probably have to get it right. Oh, how I deemed it on an over and underestimate. It was because I rounded, if you think about it, if you round the speed down, in reality it would actually be faster, so there's less time, isn't it? So it's an overestimate. Just think about, you can think about the context as well. Okay. Okay, so we've got simultaneous equations. This time we've got linear ones. Obviously it could come up quadratic, could come up as a graph one. We've got linear ones. You can solve this in 2 different ways. You can do elimination method, you can do substitution method. Normally I do elimination, but I think this one I actually did substitution for some reason. But let's go with elimination. I'm gonna make, let's make the x's the same. Again, you might make the x's the same, you might make the y's the same. It all doesn't matter as long as you get the same answer. So I'm just going to go with making the x's the same. So the first one is fine. I'm just going to times the second one by 5. If you make the y's the same, obviously just times the first one by 3. So we've got, I'm going to keep the other one, 5x plus y equals 21. And then the second one would become 5x minus 15 equals 9. Okay. No. Does not equal 9. Make sure you multiply everything. Equals 45. Subtract them because same sign subtract if they're the same symbol, and because I'm looking at the x's, they're both technically positives. I'm not looking at the y's. If you did the y's, you would add because different sign add. Same sign subtract, different sign add. I'm going to subtract them. Okay, so obviously the x's should cancel in my case. And then when I do this, just be really careful because that does become a double negative. So that would be 16y because I've got y subtract minus 15. Yeah, that's what I said. You can do elimination or substitution method. I think when I worked it out before I did substitution, that's fine. You can do that as well. It's literally a personal preference. Then I've got, obviously, subtract that. So what's that? Minus 24. Obviously, divide. That would simplify to 3 over 2 or 1.5, obviously negative. Negative 3 over 2 or negative 1.5. You can put it as either format. That's fine. Then obviously sub that into one of the originals. I guess I might choose the bottom one because it's smaller. You can choose whichever you like. Again, a lot of this is personal preference, isn't it? Minus 3 over 2. So that's, I'll probably convert in my head. I'm just going to convert it into decimals now. So that's minus 1.5 times by 3 becomes positive 4.5. You might use fractions. Again, it's all different, isn't it? Depends what you like. Take that away, we get just 4.5, or if you want a fraction, that's 9 over 2, isn't it? Can I leave it as the fraction? Let me see. I probably wouldn't, just because when I then sub it in, do you see how you'd get such a big number if you subbed in 24 over 16? I mean, it would still work. I don't know if they want the most simplified answer. Let's see. They have said or equivalent. They said fractions do not need to be in simplest form. So yeah, they would accept minus 24 over 16. I just don't know if you would. Can I use a graphical method? I wouldn't. No, you have to solve it algebraically.
So whether you do it my way, whether you do it the way that you suggested in terms of substitution, that's fine. But I would not use it. I would never use a graphical method unless they physically have given me a graph. Do you know what I mean? Unless they've shown me the graph and I need to draw it or something. I would always solve it algebraically, yeah. Because your graph is never going to be accurate otherwise, is it? And it's not an estimate, it is exact. Okay, so simultaneous equations is really nice. Okay, we've obviously got some kind of area one going on here. So the diagram shows a square, ABCD, with side lengths 20 centimeters. So I'd probably label this 20 as well, just to remind me. It also shows a semicircle with and an arc of a circle. So you see here, this white bit's a semicircle. Then over here is the arc. AB is the diameter of the semicircle. So I personally would probably draw that to just remind myself that the radius is 10 of that semicircle. AC is an arc of a circle with centre B. So that's a quarter of a circle, isn't it? A, B, C, that's the quarter of a circle. So the radius for that one is actually 20. Show that the area of the shaded region over the area of the square simplifies basically to pi over 8. Obviously, we're not going to work out pi, right? They wouldn't make you use pi as a decimal. So that's telling me I just need to work out the area of the square and the area of the shaded region, and then I'll put them into a fraction at the end. So area of the square is obviously the easiest thing, isn't it, to start with? Might as well get the marks for that one. 20 times 20, 400. So we'll leave that there. Now, the area of the shaded, I need to do, it's kind of like a cutout. I'd probably work out the area of the quarter circle. So the quarter circle, and then take away the semicircle. So area of a, let me draw it the other way around. I like to kind of draw it just so I remember which piece is which. That's my quarter circle, isn't it? Which is the area of a circle, which is on your formula sheet, but hopefully you know this anyway. Pi times the radius squared. Now just be careful which is the radius. For the quarter circle, the 20 is the radius, so that's fine. 20 squared. Now I only want a quarter of it, so I'm going to divide by 4. So that, I obviously already know that 20 squared is 400. Pi over 4 is 100 pi. Just leave it in terms of pi. 100 pi. Okay, let me see, area of square, yeah. Or x, what is x? I'm not sure what x is, what you're referring to by x. Because there's no, we're not like solving anything here, if that makes sense. Then obviously I do the area of the semicircle, which is pi times the radius squared. Now, again, just be careful, the radius of that one is 10, isn't it? Just be careful. Oh, what is that? 10 squared. And now I only want half of that, so I'm going to divide that by 2. So that's obviously 100 pi over 2. You'd have to write that middle bit if you don't want to. I'm just kind of over-explaining. 50 pi. Okay. So then my area of my shaded region, area shaded, is the whole, like the quarter circle bit, the whole of the quarter, take away the semicircle, cut out, which is 50 pi. We're almost at the end. So my key bits, obviously the area of the shaded region is this, and then the area of the square, which was this. I just need to put them into a fraction, and obviously you can see that they've simplified it too, haven't they? So you would need to simplify it as well. So therefore I would do, what was that, shaded region at the top, over 400. I think you could probably assume that as long as you knew that you'd done it right, that that would simplify, but it also does technically simplify, doesn't it? If you were to work it out, I'd just knock off the zeros. 5 and 40, that would obviously become an eighth, wouldn't it? So I'd probably just go, yeah, that's the same, isn't it? (360/80). Oh, for question 6, I was just thinking, like, what? Oh, for your fraction. Now I'm seeing where, because you said 360, I was thinking you meant the circle thing. I was getting confused. Because you had 24/16, and then I don't, did you 360/80 gives you 9/4. Yeah, that's the same thing. Gives you 9 for x. Yeah, you're right. Yeah, that would be fine, technically. Yeah, that would be correct. The quarter of the circle, yeah, exactly what you've said about it being 90 degrees because it's in a square, and we know that squares
are all like this is a 90-degree angle, isn't it? Yeah, that's why. And obviously the quarter, if I were to highlight it, the quarter of the circle is like, try and ignore this kind of cutout, is this bit here. This is a quarter, because a whole circle, that was really bad colouring in, a whole circle has 360 degrees. So 90 degrees is a quarter of 360, isn't it? Yeah. And you know it's 90 because it's a square. So that's how you should know it's a quarter of a circle. Because if they didn't know if it was half a circle, like a semicircle, or a quarter of a circle, they'd have to give you an angle, and they haven't, technically, apart from the 90. They haven't actually given any other angle. So it's not anything other than the 90. Yeah. That's a quarter of a circle, isn't it, if you think about it? Like if you were to carry on the circle, that was horrible, but you get the point. That would be the rest of it. Yeah. Okay, so that's all of that one. Obviously, you need to simplify it at the end. I'd probably just write what they've got at the end to simplify it. 4 marks is quite nice. Next question. Because the quarter, the center of the circle, why do I do 90? Why do I do 20 as the radius? Because B is the center of the circle. That's the center. If that's the outside of the circle, then that's halfway, isn't it? That's a radius. That's why. Okay. All right, question 8. This is our trig values question. So write down the exact value of tan 45. You just have to have memorized it, basically. I can't really help you beyond that. You just have to have memorized it. The answer should be 1. Now this one, they have actually given it to you. So that's quite nice, because they've already asked you once. I guess they've given you another value. So here's a right angle triangle. You can obviously see, hopefully you look at this and immediately go, it's obviously trig. But they've said specifically cos 60 is equal to 0.5. So they've kind of almost given you half of the working out anyway. Work out the value of x. So normally, yeah, that's the hypotenuse. I would label it hypotenuse. This is the adjacent. Obviously, you can see that you need to use cos because they've also told you. But my actual formula, CAH, I'm looking for the hypotenuse. So that means the adjacent over cos 60, which they've told me is a half. 4 divided by a half. You can obviously change into a fraction and do keep flip change if you like. Or you just go, how many halves go into 4? It's the same, it's double, isn't it? It's 8. I would say 60 marks is good, yeah, for the paper. What's that? 3/4, 75%? I think that's very high, yeah. Sine rule, you mean sine rule as in like actual sine rule? Because if it's a right angle triangle, you just need to use sin, cos, or tan. Not as in like SOHCAHTOA, not as in like sine or cosine rule. I don't think you can use sine. No, how would you use? I don't know how you'd use sine. Because the angles, I mean, unless you were like, oh, well, that means that one's 30, and then this is the opposite, and this is the hypotenuse. Yeah, I guess you could use sine in that sense. I don't know why you would, because then you would have to have memorized the value of sine 30, which is also a half. But yeah, I guess technically you can. If you get the same answer, as long as you get 8 at the end, I would assume that they would allow it. Yeah. So you should get 8 as well. 8 centimeters, I guess, for question 8. Okay, question 9, cumulative frequency. I think this does come up quite a lot in paper 1 specifically. That and box plots. In this case, you can see, well, I don't know if you can see that on yours. No, you can't quite see it, but it's a mixture in this case. So the times that 48 trains left a station on Monday are recorded. The cumulative frequency graph gives information about the numbers of minutes the trains were delayed. Obviously correct to the nearest minute. Now this is one I would just say be careful of, because you see obviously they've gone up to 50 on the graph, but actually this is 48. So just remember that. Just remember it's not 50, it is 48, okay? That's, again, a bit of a trick question there. So they've given us the cumulative frequency graph. Now they've then said obviously the shortest delay was 0 and the longest delay was 42. On the grid below, draw a box plot for the information. So what we need to do is they've obviously given you these two values. If they ever want you to convert a cumulative frequency graph into a box plot, they will give you the shortest and the longest, or the biggest and the smallest. And then the other 3 values that we need, which is lower quartile, median, upper quartile, you'll obviously get from the graph. So you could always start by just drawing the 0 and 42 on if you wanted. Be careful of the scale. Sometimes the scale on these graphs is kind of annoying. This one's not so bad.
Okay, and then we want to know median, upper quartile, lower quartile. So that's why I was saying be careful that it is actually 48 and not 50. It's not 50. So when I work out my median, upper quartile, lower quartile, I'm using the 48 value. So for the median, I obviously need to do half. You don't have to write this down, but I'm just showing you. I would need to do half of 48, which is the 24th. What was this? Trains, I guess, or delays, 24th one. So from my cumulative frequency graph axis, from this y-axis, 24, again, double check the scale. Sometimes it's not so great. Okay, this one's quite nice because it's exactly on 10, isn't it? You should get 10. I think that's probably really obvious, that one. So that was the median. The median is 10. So you can always draw that on. And then we want to do the upper and lower quartiles. Where did I get 40 from? I don't have 40, I have 48. 48 is the total number of delays, trains, whatever the context was. If that's what you mean by 48. I'll come back here to see 48. That's the total, isn't it? Okay. Still see that. So I'm going to draw 10 on. I draw it on different heights. You don't have to do that. You can draw them all the same height, so don't worry about that. Obviously then, lower quartile, same logic, but obviously lower quartile is 25% or 1/4, so I'm going to divide it by 4, which gives me 12, so 12th train or the 12th delay or whatever it was. The 42 came from this information here. That was where I got 42 from. Yeah. Where's my line? So from 12 across, again, that hits an exact point. What's that? 4? I would say 4. The lower quartile. How did I find the median? So you get the total, which in this case the total was 48, wasn't it? It said at the top 48 trains. And then you divide it by 2, you half it, and then that's where I went across here. You see that was at 24, wasn't it? And then it came off at 10. And then the lower quartile is 1/4 of the total. And then the upper quartile is obviously then technically 3/4, so you could just do your lower quartile times 3, which is the 36th train, which would be up here somewhere. That's one way of finding the median. In this case, you can't do it that way because we don't have all the numbers. So that's one method to find the median if you cross them all off, but that's only if you're given all of the values, which we're not here. So you can't do it that way in this particular question. You can do it in other questions. This one's also a nice exact number, 20. So what have I missed? 4. Draw the 4 on, and then draw the 20 for the upper quartile. And then obviously you need to join them up, so yours would obviously look a lot nicer than mine. I'm just doing my best with the digital version here. So the 3 in the middle should create a nice box, and then the other 2 are connected by like lines across the middle bit there. Yours will look hopefully a lot nicer than mine. Yeah, it doesn't go up to 50 because that's what I was saying. They've done that as a trick question because you see, I know that the graph says 50, but actually if you see where it stops, that's not 50, is it? And it also says at the top 48, so just be really careful what the total you're using are. I think the other thing you'd probably realize is if you did 50 divided by 4, you'd get 12.5, which is kind of difficult to mark on the grid. You're probably like, wait, hang on. Does that make sense? Yeah, so just double check. Oh, you can do that, but I feel like that you could list from 1 to 48 and then cross them off, but I don't see the point when you can just half it. Like, I think that would take too long, if that makes sense. Like, you can, yeah, I guess you could do that, but that would just take too long. Does it matter how the box plot looks? I mean, mine looks not very good. It has to be accurate, if that's what you mean. Mine's obviously a bit round, like a bit, it's not very straight, but I would say like it has to be clear enough that you do have, you know, the correct figures. So we've got 4, we've got 10, we've got 20. I think that would have to be clear enough. And also it would have to create, well, they've actually given you a second one here so you can replicate the shape of it. You'd have to have the 3 in the middle creating a box and then the 2 on the outside not. That's the extent to it. I don't know. Obviously you'd use a ruler, right? Make sure you use a ruler. Oh, look at them. The box can be of any height, so it doesn't matter how tall your box is. They've said any height. I've just done it randomly. Yeah, what else have they said? The median has to be inside this kind of box bit. Like they've said, you have to create the box. Yeah. Don't know if that answers your question. I mean that the lines at the minimum max. Oh no, that doesn't matter. I just did that out of preference. If you look at theirs, they've done it at the same height as the middle bit. So no, that doesn't matter. That doesn't matter. They've literally said in the mark scheme, the height of the box can be any. Obviously, as long as it's on the grid, right? The height of the box and the whole thing can be any height. So that's fine. Oh, you went with 12.5. That's annoying. No, just double check because sometimes it's obvious what the total is. Sometimes in this case they've done it as a trick question. They've done 48, even though it doesn't look like 48, but it is. Do you know where you drew from 12 down to 4? Can't you continue that line? Oh yeah, it lines up. You could do. I mean, I wouldn't imagine that saves time, but obviously I would then rub out the bit in the middle. Like I wouldn't have this line all the way through. I didn't notice that it did line up. I guess it does. I just never noticed that. Okay, so that's the first bit. We've obviously got 3 marks for drawing our box plot. You need those 5 kind of lines, basically. We've then been given a second box plot for the 48 trains that left the station on Tuesday. So ours is Monday, theirs is Tuesday. The box plot obviously below gives information about the delays, blah, blah, blah. Let's look at the second page. Okay, if you were in my live this morning, well, not this morning, but a few hours ago, or if you saw the video that I uploaded recently, today, we went through what to write for comparing the distribution from a box plot. So compare the distribution of delays on Monday with the delays on Tuesday. We have 2 marks, we need to write 2 things. So you always mention the median, and it says compare. You have to just literally make a comparison. So let's have a look. The median for Monday was 10, and then the median, a different colour. The median for Tuesday, what's that? That looks like 9, doesn't it? 9. I know it's very similar, but technically one is less than the other or one is bigger than the other. So I would just say in that case, and you have to relate it to the context, right? So I would say the median delay on Monday was bigger, was greater, or if you said Tuesday, you'd say it's less, you know, it doesn't really matter which order you put it in, than the median delay. So you have literally making a comparison. That's all they're asking for. They're not asking for you to explain it. They're not asking for an analysis, a reason why. It's literally as simple as that. Just compare. Seems kind of too easy, but it is. Now, the second thing is then some form of range. So you can either say the interquartile range, which is what I prefer to do, or you can say the whole range. It doesn't really matter. I like to do the interquartile range. I don't really know why, I just prefer that. So obviously the interquartile range is this bit here, isn't it? So for Monday, that would be, what do we say, from 4 to 20, so that's 16. And then for Tuesday, I've got from, what's that, 6 to 10, 17, 6 to 17, so what's that, 11? Is that right, 11? And then I would, again, just make a comparison. One is less than or one is greater than the other. So Monday is greater than Tuesday, isn't it? So that's what I would say. And you could say the same for the range. So the interquartile range of delays, again, I'm relating it to the context. Was greater than, and then you say the other one, the interquartile range, or you can put range generally if you want to put just the normal range, that's fine. As long as you made the correct comparison, obviously. That's your 2 marks. It's always the same thing. Median, some kind of range. Yeah, you have to right, so if you just say Tuesday has a lower median than Monday, you said Tuesday has a lower range compared to Monday range, so no. So what they've said in the mark scheme and what I've seen multiple times is
I think you have to at least have mentioned the context for at least one of those two. I don't think you necessarily have to put it for both. I just put it for both to be safe. But you have to put the context, which in this case is delays, or the trains or whatever, the delays. You have to put the context for at least one of them. Yeah, so I would just be really careful with that. That's why I've kind of put the effort into putting like the whole thing, just in case. Just in case. They've said 1 mark for a correct comparison of medians, and then a correct comparison of measure of spread, so range or interquartile range. And it says, for the award of both marks, at least one of the comparisons must be in context. So at least one of them. How would I mention the entire range? So you see how the entire range is like the whole thing, so 0 to 42, so that one would be 42, wouldn't it? For Monday, that's the whole thing. And the whole thing for Tuesday, 0 to, what's that, 34? 33? 1, 2, 33. So the range for Tuesday would be 33. So I'd say basically the same thing. The range of delays on Monday was greater than the range of delays on Tuesday. Just literally a comparison, which one is greater, which one is like less. Would hard bounds calculations? Probably not. If it's a hard bounds calculation, I would assume there's probably loads of decimals. So I'd assume maybe not. I mean, upper and lower bounds could come up generally if it was maybe easier. But I think if it's loads of decimals, you know what I mean? It would probably be more likely paper 2, paper 3. Okay, so that was part B. Always the same. If you see that question, perfect. Really easy. Now, Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 and 30 minutes. Is Mary right? So let's go back. So we're saying, what was it, Tuesday, I think? Yeah, Tuesday. We're saying Tuesday. She says 25 to 30. So that's here to here. Okay. The reason for this one is, yeah, this line here is the upper quartile, isn't it? And this is like the maximum or the greatest or whatever. We know that there is 25% of the data between the upper quartile and the maximum. So there are delays between, what's this, 17? There are delays between 17 and 33. However, we don't know the spread of those delays. We obviously know one of them was 33 at least to be the biggest one. We know one of them was 33. But we don't know, maybe all of them, apart from, the 33 one, maybe most of them, let me get a different colour, were here. It doesn't guarantee that they're between 25 and 30, does it? It doesn't guarantee that. So what does she say? She said, this means there must be some delays between 25 and 30 minutes. Well, no. It doesn't mean that there must be. There might be. It's not impossible. There might be, but it doesn't mean that there are. Now we need to obviously explain why. How would we word this? That's the thing, isn't it? Trying to figure out how to word it. Something like, there may be only delays, I don't know, however you want to word it, between, we said, obviously, 17 to 25, and then 30 to 33. Like, it's not guaranteed that they fall between 25 and 30, is it? It's not guaranteed. It's possible, but it's not guaranteed. And she was saying it must be. It's not guaranteed. Yeah. So there might not be. Some kind of version of that. Yeah, for trig values, I would probably search it on YouTube, find different, because there's different ways. I have a way of doing it. I don't think it's the most efficient way of doing it, personally. So I won't tell you that way, because I don't think it's very efficient. But yeah, I've heard that there are different hand tricks and things like that. So I'd probably just search it on YouTube. Have a look what other people are saying. Okay. Question 10, we've got technically algebraic fractions, I guess, but kind of a simpler version, isn't it? So simplify this. Technically, I can cross out x minus 1 and the squared. However, I think the reason why they've done this is because technically, it doesn't disappear, the numerator. You're still dividing by whatever's left. So technically, there's just a 1 left there. There's still a 1 in the numerator. And then there's just 5 times x minus 1 once in the denominator. You said no, 0 and 35. No, I don't think that would get the marks. First of all, 35 minutes is too high. It only goes up to 33. I think you have to be specific about this upper quartile section. Oh, wow. Beyond the upper quartile and then the max section. 17 to 33 bit. I don't think that would give you the mark. So yeah, be careful with this. If you're dividing or cancelling something out of the denominator, it doesn't just disappear. It's still a 1 over 5x minus 1. You can expand that if you want. I probably just wouldn't bother. Now, the denominator part B is something that comes up. It will always come up. I can guarantee you. It will always come up. Whether it's paper 1, paper 2, paper 3, I don't know, but it would come up in one of them. Is hopefully you'd recognise difference of 2 squares. So the squared bit disappears because I divided like the top, I divided by x minus 1. Do you see how that left me with just 1 because it's divided by itself? And then the bottom I divided also by x minus 1. That's how I cancelled it out. So instead of it being x minus 1 squared, it was no longer squared. It was just 1 left, if that makes sense. Can you expand the... Yeah, if you give your answer with this expanded, that's fine as well. I just wouldn't bother personally. So this one is difference of 2 squares. It's kind of hidden though, because obviously you're thinking, well, 50 is not a square number, 2 is not a square number. When I say factorize fully, I feel like that's a key. It's a key kind of point to say there's probably 2 steps here, not just 1. Because I think naturally you could go, yeah, I can obviously factorize out 2. That makes sense, doesn't it? But that's not the final answer. This bit here is then difference of 2 squares. 25 is a square number. Y squared is obviously a square number. Difference. So you need to factorize it like that and then put it into the double brackets for difference of 2 squares. So you square root both, so you get 5, y, y, and then 1 is plus, 1 is minus. Make sure the y does come second in that case. Let me see the marks. Mark 1 is for partial factorization. Yeah, so if you wrote this line here, that's 1 mark. Obviously then the second mark is for the final completed answer. But yeah, this is the key thing. When they say factorize fully, they're kind of implying that there's probably 2 steps to go. Do you know what I mean? It's not just factorize, it's factorize fully. And there's 2 marks as well. Is that right? No, that's not right, because the only reason why that's not right is because if you expanded it, the y has to be the negative. But if you expand yours, you're going to get positive y squared and negative 25. But it's the other way around. Now, you could write it the other way around. Like, they'll accept, I think, if you did y plus 5, and then if you did minus y plus 5. I think that also works. Does that work? I think that also works. I think they'll accept that. But do you see how the y is still the one with the negative? Yeah. Yeah. So I just left it in the same order. Do you see what I mean? Like the 25 was at the start of the bracket, so I put the 5 at the start of the bracket. The y squared was at the end of the bracket, so I put the y's at the end of the brackets, if that makes sense. I just kind of kept it like that just to keep it simple. Yeah, I think they've done that. Again, they've done that. Like all these little details, I think they choose them deliberately just to see. They've also... what do they also accept? They've also accepted, if you did... I don't know why you would do this, but... Oh, so if you'd put minus 2 on the outside of yours, you would have got it right. Yeah, difference 2 squares. Yeah, if you factorize out wait, is that what you put? No, you didn't. Yeah, this is another option of what they've suggested you could put. I didn't personally think to do that, but they have put that as another suggestion, yeah. But if it was just positive 2 on the outside, then no. Okay, so yeah, difference 2 squares, make sure you know it. It will come up at some point. I can guarantee that. Okay, this question I thought was quite hard, actually. This was quite hard to get my head around. It's only 3 marks, but I felt like it was kind of hard to get my head around it. So, Jack and Sadia work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. So, here is Jack's idea for the special offer. He said to put 25% more cereal into each box and do not change the price. The same price, 25% more cereal. Here is Sadia's idea. Reduce the price and do not change the amount of cereal. So she's going to reduce the price, but keep the same amount of cereal as originally was there. Yeah, I found this one really quite hard to get my head around. So Sadia wants her idea to give the same value for money as Jack's idea. By what percentage does she need to reduce the price? obviously there's loads of different ways to work this one out. The way that I did it is I kind of put numbers to it. Sometimes when there aren't numbers, I like to put my, I kind of chose my own numbers. So I think what I did, to be honest, I still found it kind of confusing, but anyway, is I said, let's go with, let's say originally, I put like 100 grams. I know it's probably more than 100 grams, but I put 100 grams. Let's say it's 100 grams. You could put it for 100 pounds if you wanted. I just personally put it for £1 because I thought, in my head that made sense. I said, let's say it costs £1 originally. So for Jack, he's kept it at £1, but then do you see how 25% more would be 125 grams? That's what I did. You can do it differently, that's fine. But that's what I would do. And then for Sadia, I then said, okay, well, they've reduced the price, do not change. So Sadia's still got 100 grams of cereal. And then I tried to figure out, like, if this is X, I guess. So scroll down a bit. That's what I did. You can choose different numbers. You can do it a different way. Absolutely fine. Now, is there a better way to do this than the way I did it? The way that I did it, which I think is probably... I just divided it. I just divided it. There's probably different ways to do it. I divided it, so I got 1 over x on that side, and then 125 over 100 on this side. I didn't put it as a decimal. You can put it as a decimal. I didn't put it as a decimal, personally. I left it as a fraction. So I simplified this fraction, because that should give you 5 over 4, I think. And then if I solve this, you have to like cross multiply, don't you? Cross multiply, so you get 4 is equal to 5x, and then you see how x is then equal to 4 over 5. Now, then I converted this into a decimal, and I said, well, I know personally that that's 80% or 0.8, isn't it? So 80%. Now, just got to be careful. This is why I'm saying it might be still complicated. The price of her cereal was, well, I guess that was like 80p, wasn't it? 80p. So what's the percentage reduction? The percentage reduction is 20%, isn't it? She's from 100% to 80%, we've reduced by 20%. So the answer is 20. Why? What is cross multiply? When I say cross multiply, I just mean like, do you see how I multiplied x onto one side and then I multiplied the denominators? Look at the arrows, yeah. I multiplied 4 onto, I just call it, you don't have to call it that if you don't want to, I just called it that. I just did it in one step. You might do that in 2 different like steps in your working. I just did it straight into one step, if that makes sense. Oh, why are we zooming? Okay, so your answer is 20%. As I said, you might have done it a completely different way to me. As if you've got 20%, I would imagine that that's fine. Yeah, this is the thing. Because no one really, most people aren't looking to get 100%. There are going to be certain questions where you look at it and go, do you know what? I have absolutely no idea. So I'm just going to move on, carry on with the paper, go, do you know what? I'll just find the 3 marks somewhere else. Maybe if you have time at the end, come back to it. If you don't worry. Just try and get 3 marks somewhere else. Do you know what I mean? Don't spend like 20 minutes on this question. It's not worth it. 1 to 5 times by 4. Oh, you mean for this bit here? Times by 5. So 4 to x. I'm not really sure what you mean. If you get the same, if you get 4/5 is x, if you did it this way, like if you get that at the end, I guess so. It's quite hard to kind of realise when it's not written mathematically, it's quite hard to interpret what you're saying. Yeah, I've only seen one question like this before, so I also wouldn't really stress. Yeah, it's a very complicated question. I think I also struggle to figure it out myself as well, to be fair. So I wouldn't stress about it. Composite functions will be towards the end. They won't be at the start of the question, start of the paper. They won't be at the start of the paper. They'll be like question maybe 18, 19, 20. So no, we haven't come past functions yet. Okay. Question 12, we've got circle theorems, but they have put it as question 12, so I'm holding out hope that it's not too difficult, right? So we've obviously got A, B, and C are points on the circumference of the circle O. DAE is a tangent, as you can see. They've obviously labelled 2 of these angles. Work out the size of angle CAO. We obviously need to identify what that is first of all. So C to A to O is this bit here. This bit here.
you must show you're working. So in this case, they haven't asked for reasons. So just double check. Have they asked me for reasons? Have they not? In this case, they haven't, so I'm not going to bother with the reasons. I'm not going to write them down. I keep saying this for all the questions. For circle theorems, there's loads of different ways to do it. So you might have done a different method to me. If you've got the same answer, perfect. That's fine. Yeah, I think there's a way that you can use alternate segment. There's two different ways I think you can use alternate segment theorem in this one. So I think the first thing, well, it doesn't matter. It doesn't really matter which order you do it in. If you're saying alternate segment theorem, the first thing I did was I said 56 is the same as this one. And they will also mark it if you label it on the diagram. I'm pretty sure you don't have to necessarily write it. But you might want to write BCA is 56 because of alternate segment theorem. Okay, because of alternate segment theorem. Then what you could say is, okay, I know that I've got a radius here, OA, and I've got a tangent. So we all know that 90 degrees between a radius and a tangent. So you could work out OAB. OAB, which I think that's the one you're referring to, is obviously 90 minus 56. That's the one that gives you 34. Angle A is that. Yeah, I think that's what you mean, right? Angle. This one is 34 here. This one. That one's 34. And then what I did is I said, right, this is an isosceles triangle. OAB is isosceles because that's a radius and that's a radius. So therefore, this angle is also 34 because of an isosceles triangle. And then if you just try and zoom out in your head, just look at the triangle ABC. Just a triangle. The only thing missing is then the pink angle, isn't it? So OBA I said was 34. And then my last step was I just did angles in a triangle. So what was it? CAO that they wanted. Obviously 180 because they add up to 180 minus the other ones. If you can still see that. Kind of, yeah. We've got, what have we got? 34 next to it, plus the other 34, plus the 35, plus the 56. And then you just take that away. That's what I did. OAC. OAC. You can use the arrowhead to work out this one, and then it would be that one would be half of 56. That's the arrowhead. Unless you were to draw a line, like if you can always draw lines on these things if you want to add your own lines. If you draw a line, no, I'm not sure. Yeah, the answer's not. Yeah, if you draw your own lines, that's also fine. So what did I get here? That was 30, 60, 90, 140, plus 10, 150, 159. You can obviously do column addition if you want to. So you should get 21. I think someone mentioned 21. Yeah, you can always draw lines in. As long as you got 21 at the end, then I would imagine that it was fine because you can't just randomly guess the right answer. So yeah, you can always draw your own lines on. That's fine as well. Angular circumference is half the angular center. Yeah, the angle O. Sorry, I know you said that like ages ago. The angle O kind of on the other side would be 28 if you were to use that. A transect. I don't know what a transect is. Do you mean a tangent? So yeah, I think that one wasn't too bad. I mean, as I said, different ways to work it out. I think I worked it out a different way when I first did it, and then I saw that way. Only 3 marks because there's no reason. You don't have to write reasons for this one particularly. So that wasn't too bad for a circle theorem. Okay, we've got some kind of describe one. I think this is quite common as well. Some kind of maybe describe a single transformation or maybe do some kind of transformation with a shape. So just double check which way round they're asking. So in this case, they've said from A to B. So it's getting smaller. I feel like naturally you want to look at the one that gets bigger. It's getting smaller. So obviously it's an enlargement. That's the first thing to say. Enlargement. Saying enlargement, I've just realised, will not give you a mark. You have to say something else. Oh, can I go back for 5? Hang on. You can also zoom. You can also like scroll the... Yeah, you can go back. You can drag it back. Oh, I can't remember the word. Do you know what I mean? You can rewind it, the live yourself and go back if you want to. But yeah. And pause it, and this will also upload afterwards later on, so you can have a look at it then as well. So it's an enlargement. That's not enough to give you 1 mark, though. Unfortunately, you need to mention one thing at least about the enlargement. obviously to get 2 marks, you need to mention the 2 things about an enlargement. So I think the easiest thing is the scale factor, isn't it? Enlargement has to have a scale factor. So it's gone from A to B. That's why I say it's important to know which direction. I just choose one side. So maybe I'll choose this side and compare it to the same side here. Make sure it's the same side. It's obviously like 3 times smaller, isn't it? So it's a third. But, and I think this happens a lot in particularly higher tier, obviously, is that not only is it a third the size, but you see how it's flipped? Like the whole triangle is flipped upside down. It's flipped upside down. So that means it's a negative scale factor as well as the 1/3. The 1/3 is the size, the negative is like the inversion, like the flip, the rotation, I guess. Now, that would give you 1 mark. We then have to mention something else, which about enlargement, we always want the center. So you mentioned about drawing the lines. This is probably when I would draw the lines, because it's not exactly in the middle, because not only does your triangle get 3 times smaller, but the distance from the center gets 3 times smaller. So it's not exactly in the middle. So just make sure that you are joining up the correct corners, right? So this is this one here. Obviously the 90-degree one to the other 90, you can see at this point. Once you've done 2 of them, you can kind of see where it's overlapping. But yeah, when it inverts, just be careful you do match up the correct corners as well. You can see they all overlap on 2, 2. So that would be like your second mark. So as long as you say enlargement and one of those 2 things, you'll get 1 mark. If you say both of those 2 things, you'll get 2 marks. So the scale factor is -1/3 just because they're going from A to B. If it was B to A, then yeah, it would be 3, like, well, -3. But just be careful which way round they're asking. In this case, it's the one that's, it's like in the direction of going smaller, isn't it? Do you see how also the distance from the smaller triangle is much closer to the center than this distance? It's not exactly in the middle. So hopefully that's a nice one. I feel like a lot of the time when it says describe a transformation, a lot of the time it's an enlargement. Not always, but a lot of the time it's an enlargement. Okay, question 14. Work out the value of 16/81 to the power of 3/4. So fractional indices, we just need to memorize this, like memorize how they work. So the denominator is the type of root. We're gonna, well, I call it 4th root. I don't know if that's actually what you meant to call it, but that's what I call it. Both of the numbers. And then the numerator is just like a normal power. So you do the denominator first. Now, I keep saying this. Yeah, your scale factor was wrong. You have to put 1/3, not 3. Well, as in -1/3, not -3, yeah. If you wrote enlargement center 2, 2, you would get 1 mark. So because the scale factor was wrong, you would lose the second mark. Yeah, you have to pay attention to which way round they want the scale to go. Okay, so we want to do the denominator first, which is a 4th root. Now, again, as I said, they won't make you square root, cube root, root anything that's not already that type of number. So not already a square number, not already a cube number, whatever it is. So this one, I just want you to kind of, you can almost make an educated guess, but hopefully you just recognize it. The 4th root of 16 is 2. It's not going to be a decimal, right? It's going to be a nice number. And then the 4th root of 81 is 3. If you think about it, 3 to the power of 4 is the same as 9 squared. 2 to the power of 4 is the same as 4 squared. So that's that. But then obviously I do then need to cube both numbers. So you should get 8/27. Okay, so don't panic and think, oh, I don't know what that is. That's the decimal answer. It's not. They will actually make you cube root or root something that you can physically do. And if not, make an educated guess. Just think, well, 4 squared is 16, so it's got to be smaller than 4, and it's got to be an even number. So what's that? 2. 9 squared is 81. It's got to be smaller than 9, and an odd number. I feel like you could probably make an educated guess, yeah, if you weren't sure. But hopefully you'd recognise those numbers. Part B is a little bit harder. I think I put this in one of my videos on the hardest indices questions. So this is just thinking about reversing the process. You know how to apply a fractional indice to make it into a root, but think about the fact that that goes both ways. If I've got a root, I could rewrite it as a fractional indice, and the same with negative indices, right? So 3 to the power of a is 1/9. Now we want to first write it as something to the power of 3, right? So I would rewrite that as 1. You don't have to put it in this many steps, right? But I'm just kind of over-explaining it. It's the same as 3 squared, but then what is 1 over? When it's 1 over, that's the negative power, isn't it?
Like if you got 3 to the power of negative 2, you would do 1 over 3 squared, wouldn't you? So think about it as the opposite way round. Okay, so just do it the other way around. So therefore A is negative 2, and then the next one, 3 to the power of B, 9 root 3. So first of all, 9 is 3 squared, and then it's multiplied by the root 3. Root 3 is the same as 3 to the power of a half, isn't it? Just think about it in the opposite direction. 3 to the power of a half, isn't it? Square root of 3. So, and then this one would include index laws, wouldn't it? I'd have to add the powers, so either 5 over 2 or 2.5, whichever you want to do. So B is 2.5. And then I think C is just a combination of the other two, basically. So as long as you got the first two, you'll get C. So 1 over 3 to the power of, well, root 3 is 1 over 3 to the power of a half, and then we just said if it's 1 over, it's a negative power, isn't it? So that would be, I'm just making it into a decimal just for the next bit. 3 to the power of negative a half, or 3 to the power of negative 0.5. So C is negative 0.5. Now they have then asked us to add them. So minus 2 plus 2.5 is 0.5, minus 0.5 is, unfortunately, 0, which is, I feel like, very annoying. Yeah. So you're just writing it in the format of 3 to the power of something and then taking those powers and adding them. And unfortunately, after all of that, it's only a 0, which I feel like is kind of annoying after all that work. But yeah, it's just 0. It's just working out, can I do negative and fractional indices in both directions, if that makes sense? Because that you can convert them both ways. Yeah, I think that you would doubt it, wouldn't you? You'd definitely doubt it if it was 0, but it is. So, unfortunately, that's the answer to that one. Okay, I think this is another topic that people really struggle with, because once you know what to do, it's fine, but it's like, yeah, you just don't really know what to do initially. So 3 solid shapes, A, B, and C are similar. It's always similar 3D shapes, right? The surface area of shape A is 4 centimeters squared. The surface area of shape B is 25 centimeters squared. Hopefully you've noticed that it's a bit of a, not really a coincidence that they're both square numbers. Okay, so they will choose, if it's a ratio or actual things they've chosen, square numbers. The ratio of the volume of shape B to the volume of shape C is 27 to 64. Again, I want you to recognise those are cube numbers. Volume is centimetres cubed, isn't it? Cube numbers, volume, 3D, all of that. They've chosen those numbers deliberately. Work out the ratio of the height of the shape A to the height of shape C. So we've got quite a lot going on, but don't worry about, I know they've not said what type of shape it is. Sometimes they give you a shape, don't they? I've seen one where it was like a chess piece. Obviously, we're not going to use actual formulas here. We're not using like area or surface area or volume formulas. We're just going to really simplify it as much as we can. And I think about it in 3 different things. You've got, in this case, they've said the height, which is like a one-dimensional thing, isn't it? 1D, one-dimensional. Or the side length or something like that, the radius, that's one-dimensional. You've then got surface area. Don't worry about the surface bit, just think of area. That is 2-dimensional, isn't it? Squared. And then you've got the volume, which is 3-dimensional, or, in other words, cubed. That's how I'm going to break it down. Okay, I literally simplify it like that. Don't start thinking about what formulas you need. Just think about squaring, cubing, cube rooting, square rooting, all of that stuff. So, you can lay it out in different ways. I'm just thinking how I was going to lay it out, because it's also got 3 different parts, isn't it? So we've got A to B area, which, as I said, is 2-dimensional, 4 to 25. They've deliberately used those values, okay? They've deliberately used square numbers. So think about it. How can I make it into a that's 2D, isn't it? How can I make it into a one-dimensional thing, which in this case they've said the height, but it could be anything one-dimensional, one-dimensional. Just square root it, okay? So 2 to 5. Now that's the ratio. It's not necessarily that the height is 2 centimeters. It's just that the ratio is 2 to 5, okay? That's for A to B. So we've got something for A. Now looking at, let's do B to C, because I know it's separate. We've got the volume then, haven't we? The volume is 3D. 27. Ooh,
to 64. So to get to the height, to get to one-dimensional, a one-dimensional ratio, one-dimensional measurement, I need to cube root, which is why they've chosen cube numbers, 3 to 4. So do you see how now I've got two separate ratios, one for A to B, one from B to C? Obviously, to get A to C, I need to combine them, don't I? This is just now 3-part ratios, isn't it? Yeah, because this is November. This is technically the retake paper. I always feel like the retake, or well, the November papers feel a little bit different to the normal June ones. I don't know. Maybe that's just me. I do feel like they feel a little bit harder or a little bit just different somehow. Anyway, so now just ignore the context. Now we're just saying, how do I combine those two ratios? Well, they both have B, so I need to create, obviously, a 3-part ratio where they overlaps. So the lowest common multiple of 5 and 3 is 15. So that would become, oh, that's not my pen. That would become 15, wouldn't it, here? And I would have to have times that by 3. So that would become 6. This one to become 15, I'd have to times by 5, so that's 20. So then, A to B to C, 6 to 15 to 20. Now, they have only asked for A to C, right? So I'm just showing you. Therefore, I can pick out... they said it's simplest form, haven't they? Hang on. A to C, I can pick out as 6 to 20. And then I would just simplify it. So 3 to 10. That's what I would do. But the point is that I would just say that I'm creating ratios, and then to get to, in this case, they wanted the one-dimensional measurement, didn't they? Square root, cube root, whatever you need to do. If you need to go the opposite direction in a different question, sometimes you need to take the one-dimensional measurement and make it into a volume, cube it, things like that. Just simplify it as much as you can. Question 14. 2 plus a half. 2 plus a half is 2.5. Yeah, it is. 2.5 is like 2 plus a half is 2.5. Yeah. No, it's for people if they didn't, like, let's say you got a 3 in your paper, if you didn't pass, you would have to retake until you're 18, and then at that point, if you still haven't passed, then you'd have to, I think, pay to retake. But obviously, hopefully in those 2 years you would have passed. If you're adding the fractions like you've just said, you'd have to make them have a common denominator. So it would be like 4 over 2 plus 1 over 2, which is 5 over 2, which is 2.5. If you're thinking about it in the context of fractions, you have to have a common denominator. You can't just add them like straight. Okay, we've obviously got recurring decimals to fractions here. So I think we went through one earlier today. Oh, actually, I think this is actually the exact same question we went through earlier. But I have seen Edexcel, they tend to be a lot of the same ones where you've got 1 digit which is not recurring and then 2 digits which are. So it's a very similar question. So for those of you who weren't there earlier or haven't seen my video that uploaded like 2 hours ago or so, then I always make x equal to the decimal, depending, they might have already said x is equal to it. Fine. We want to obviously isolate the recurring part of the decimal. The reason why I want 10x is because 2 is not recurring. I want to get 2 out of the way. Do you see how now I'm just focusing on the recurring part, 5, 6. Now, you want 2 of those. You need 2 equations with the same recurring decimal and also in the same order. So to get another version of this, I would have to multiply by 100, which would give me 1000x on one side, and multiplying 10x by 1000. By 100 is 1000x, and then 256 point another 5, 6 recurring in the same order. It has to be the same order. This is quite easy. It's just a specific method. If you memorize the method, then it's easy. But if you don't know the method, then it's, yeah, I would have no idea. Once you've done that, once you've got 2 equations with the same recurring decimal isolated, you then subtract the equations, which is why I put it that order. I put the bigger one at the top just to make it easier. Subtract them, 990x. And then on this side, the whole point of me getting them in the same order is that I can cancel out the recurring decimal. Obviously, don't forget to minus the 2 in this case, so that'd be 254. And then divide. obviously by 990 in this case. Now, this one, they have actually said a different fraction, do you see? So they've actually, all they've done is simplify it by dividing by 2, haven't they? So I would just write that as well, equals to whatever they've got. Double check, sometimes they ask you to give it as in the simplest form, sometimes they don't even care, so it just depends on the question. Okay, so that's the method that I would use. I think as long as you've memorized this method, it's quite nice. I have got a video on this if you want to look through more examples, but yeah, it's quite a nice one, that one, I think. 3 marks. Question 17. Okay, now we're getting into what I class as, I guess, the harder ones, isn't it, at this point? So we've got, here's a sketch of a curve. You can obviously see, hopefully you'd recognize it is a quadratic. More specifically, the curve of the equation, the equation of the curve is y equals x squared plus ax plus b, where a and b are integers. Okay, 2 things we don't know, 2 numbers we do not know. Then they've given us coordinates. Now, first of all, when I first read this, I read it wrong. So just make sure you're really paying attention to what it is. 0 minus 5 is this one here. I like to label my graph just so I can visualize it. And then 5, 0 is obviously this one. When I first read it, I thought they'd given me both of these, and I was like, yeah, but that's not symmetrical, so why does that make sense? It's because the other one is the y-axis one. Okay. Yeah, exactly. You said complete the square. Okay. We would need to complete the square to find the turning point coordinates, but we can't complete the square if we don't know these 2 values. So we need to find the values first, and then we can complete the square at the end. How are we going to find those values? Well, there's 2 things missing, 2 letters missing, and there's 2 sets of coordinates to sub in. So I was thinking just sub them both in and see what happens, right? So sub the first one in. We've got, make sure you put it in the right way around. Y is minus 5, 0 squared plus, I mean, you don't even have to write this out fully if you don't want to, but plus b. Do you see how that would tell me that b is minus 5? You could probably, I mean, just from looking at it, we know b is minus 5 anyway, but just so you've got something to write down. B is minus 5, okay, great. Now, what I would do is I would then sub in the other set of coordinates, but I would put the b in as well. So 0 for y, 5 squared plus 5a, and then put the minus 5, because you can't solve an equation if you have 2 letters, right? So minus 5 from the b. And then solve it. So we've got 20 plus 5a, so minus the 20, divide by 5. You see where we're going with this. Again, there's a different way to do it, but this is the way that I was thinking. Okay, so we've got our equation, y equals x squared minus 4x minus 5. That's the equation of the curve. And then we can complete the square. Yep, so now we can complete the square. Yeah, you got minus 4 exactly. How you find the turning point after... Yeah, so you can't complete the square until you've got the whole equation like this. So I just subbed in. I don't know. I feel like when you don't, like, if in doubt, if they've given you an equation and they've given you like coordinates, you might as well just sub it in, mightn't you? Might as well see what happens. Some of this might be just trial and error and see what happens on the day. You might not necessarily know what you're doing as you go through it. You're just like, oh, I might as well sub them in because something might happen when I do. Do you know what I mean? Like, you could just test it out. So I've subbed it all in. I found out the values of b and the values of a by using, so I can tick this off. I've used all of that now. Now I need to find the turning point coordinates, which is where I just complete the square of my quadratic, which is this one here. So completing the square, we write x, we copy the same symbol, and then we divide this value here by 2. So that would be obviously 2 squared. You then, on the outside, subtract. You always subtract this bit that's in the fraction, in the brackets squared. So technically it's minus 2 squared, right? You don't have to really write it fully. You could work it out straight away if you want. And then obviously the minus 5 is still there. So just be careful when you're squaring negative numbers, it becomes positive. So that would be positive 4, but I'm still subtracting it. So that'd be minus 9, wouldn't it?
Let me have a look at the comments. Yeah, so I'm getting to the turning point now. Now I'm doing, it's kind of like 2 questions in one. They're like 2 different questions, if that makes sense. Now I'll show you how you get a turning point from that. Yeah, we had to find the equation first in order to complete the square, but we did that, didn't we? We subbed in coordinates to find the equation. No, factorizing and changing the symbols is where you solve an equation. We're not solving it. We're completing the square. What values? The values that they gave us coordinates here, didn't they? I've just ticked them off. These values. Oh, hang on. It's probably confusing because they're all the same, like 0s, -5s, and they all swap, and but they're all still 5s and 0s. I think that's why it's confusing. So this one I subbed in here. Do you see? That's the one I subbed in there. It gave me that B was -5. And then this one I subbed in here. Like after I found out B, I subbed it in here. Do you see? And then the B was, I also subbed in B. And then it gave me A. Right, so we're not solving, okay? We're not solving the equation. We're not trying to find, like, I know we're trying to find a set of coordinates, but we're not solving it. Because if you solved it, well, I mean, we can't, right? We don't have any values. So now to get my turning point coordinates, we just take whichever is in the brackets with x is your x coordinate. However, you do have to change the symbol. So that would become a +2. So that one's 2. And then the y coordinate is the one on the outside. Keep it the same. If it's already negative, keep it negative. If it's already positive, keep it positive. Okay. Yeah, so to do the points where it crosses the graph, you would put it equal to 0 because it crosses at 0. You'd make that 0 and you solve it. But they haven't asked us to do that, right, in this question, so I won't do that. But if that was the question, you'd put it equal to 0, and then you would, as you said, you could factorize it, you could use quadratic formula, you could complete the square and then solve it that way. There's 3 different ways to solve it, but they haven't asked for that. Okay, so that's why I've not done that in this case, because they didn't ask us to find that. So you should get +2, -9 as your turning point coordinates. It's a bit of a, what I'd call like a random question. It's quite a niche question, isn't it? Because obviously completing the square comes up loads, but the first part of that question, I've not really seen something very similar to it before. So again, it might not be something that they actually repeat. Did they ask for completing square? They didn't say it in the question, but as in, if you ever see a quadratic and then you see turning point coordinates and you can't obviously visualize, you can't literally see what it is on the graph, it means completing the square. Well, the thing is, we've already got one of the solutions. One of the solutions is 5. So they've already given us one. So like, because this is where y is equal to 0, isn't it? So you would just put that equal to 0. You could complete the square to solve it. You could do quadratic formula. You could, I'm assuming we can factorize it. I don't know, let's see, can we factorize it? Obviously 5 and 1, -5 plus, yeah. So then x is -1 or 5, which we already know the 5. So technically this is -1. We don't need to know that for this question, but technically that's how you would solve it. Okay. Obviously you would have to know the equation to do that. Okay, I'm going to move on, guys. So, because that's quite a random one, I feel like as long as you get the completing the square bit, that's the most important bit of that question. So we've got some graph transformations by the look of it. The graph of y equals f of x is shown on the grid below. Another quadratic. On the grid above, sketch the graph of y equals f of x minus, I can't even read it, f of x minus 2. There we go. X minus 2 is in the bracket, so we have to go, what is that? It is a translation, and it's on the x-axis. This is how I just go through it. Which direction? The x-axis is always something wrong about it. So it's not -2, we're actually going 2 to the right. So the x-axis translation is always something opposite. Okay. Oh, niche. Yeah, I just mean niche, like very, 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 very specific. Niche. It's like such a specific question that I don't know if they would repeat it, is what I mean. Obviously, completing the square, yes, they will repeat that probably every year. But the actual first bit was quite specific, wasn't it? So I don't know if they would repeat that exact same question again. That's why I'm saying not to kind of stress out about it.
So this I just need to move everything 2 to the right. So just pick a few, because it says sketch, just pick a few exact coordinates. So like the turning point's a nice exact coordinate, that would go here. Maybe where it crosses the axes would go to 2 and then 4, and then maybe these 2 up the top. Just so I've got something to map out. There. Oh, no. Nope. Over here. There we go. And then you just roughly, oh, that was horrible. You would obviously do a much better job than I would on a piece of paper. Just try and make it look roughly like a U shape. Okay, so that's part A, that's 1 mark. You just have to memorize the graph transformations. I can't really help you beyond there. You just have to memorize them, what they mean. Okay, on the grid, graph A has been reflected to give graph B. So again, just double check which direction we're going from A to B. The equation of graph A is y equals g of x, so write down the equation of graph B. So how do you translate a reflection into the kind of format that you would write transformations? Reflections are always a negative, isn't it? Just there's no numbers, just a negative symbol. But we are reflecting in the y-axis, aren't we? So where does that negative symbol go? Again, you just have to have it memorized. We're reflecting in the y-axis, but it's affecting the x-coordinates, isn't it? So you would put the negative next to the x, not on the outside. Why is it 2 to the right, not to the left? Just because with the x-axis, it's always the opposite, pretty much. It's just something to memorize. Okay. Alright, so that one's a bit harder because it's kind of doing the reverse. You're basically having to take what's happened and put it back into an equation. So it's a little bit harder. Okay, graph transformation. There's only 2 marks that question though, so again, if you didn't get it, I wouldn't worry. Alright, whoever was asking for composite functions, they are here. We're on question 19 now. Alright, okay, so for all values of x, we've got f of x is x plus 1 squared, and g of x is 2, and then multiplied by x minus 1 in brackets. Show that g of f of x is basically, we should get to this point. So it's always subbing in the wrong way around, isn't it? When I think of composite functions, it's always a reverse. So I'm taking the whole of f, and I'm going to put it into g. The whole of f into g. And when I say into g, I mean wherever there's an x in the g part. So I probably need a square bracket. So instead of x, I'm going to put x plus 1 squared. And then I still have the minus 1, don't I? Okay. And then all I would do from there, oh, where's my 1, is I would just expand it until I get to the same point, and maybe I'd have to factorize it again. So let's do some expanding. We've got, this is x, this is like double brackets, isn't it? So don't just square the x and the 1, you have to square, like you have to multiply everything. So we get x squared. When I simplify it, I get 2x plus 1, and then technically there's a minus 1, right? So those would cancel each other out. So then I get 2 brackets x squared plus 2x. However, have a look at what they've got. They've also pulled out the x. So pull out the x just to match what they've got. Okay, then I've got the exact same thing. Okay guys, let's just focus on the questions, yeah? Otherwise I will have to just kick some of you out because it's not really helping, is it, everyone else? So inverse function, okay, well, we obviously need the function g. Let me write down g just so that we can see it. I think it was 2x minus 1, wasn't it? Yeah. So the original was 2x. Obviously, you'll be able to see it as a whole thing on your page when you do yours, but we're just looking at a small part of it. So the inverse function, and then we've got 7 as well. So I'm going to do the inverse function of g, and then at the end, I will sub in the 7, okay? So inverse function of g, I just normally put y there. I think that's normally what most people do. You can obviously swap the x and the y immediately if you want, or you can swap it at the end. I tend to swap it at the end. It's up to you. So now I'm going to make x a subject. So you don't have to do this, but I'd probably expand it first. And then I would obviously add 2 and then divide by 2. Over 2 is x. Okay, and then obviously rewrite it, right? So the inverse function of g is swap the x and the y at the end if you've done it my way. X plus 2 over 2. Now, I'm going to sub in the 7. Now that I've done that, I'm going to sub in the 7. 7 plus 2 over 2, so that's 9 over 2. You can leave it as 9 over 2. You can obviously put it as 4.5 if you want. Same thing, isn't it? Let's see what they've said in the mark scheme. Yeah, 4.5 or equivalent. So 9 over 2 would be fine. 4.5 would be fine. Some kind of fraction would be fine. Okay. So that's the function. That's quite a nice functions one, I thought. It wasn't super complicated. Okay, I think we have, what, 3 left? We're coming up to the really hard vectors one as well, so you'll probably want to see that. So we've got surds. Obviously surds, I feel like quite a good one to put in non-calculator, because otherwise you would just put it in your calculator, wouldn't you? So make sure you know your surd rules and rationalizing and all of that. Okay, show that we've got root 18 plus root 2 squared over root 8 minus 2 can be written in the form a brackets b plus root 2, where a and b are integers. They want us to rationalize it. Could you put 45 over 90? Well, no, that wouldn't be the same, would it? That'd be a half. If you put 90 over 20, then yes, that would be fine. I don't know why you would put it like that, but anyway, yeah, I don't know why you would do that. 45 over 90 is not the same. 45 over 90 is the same as a half, which the answer wasn't a half. So as long as you get the fraction correct, then yeah, fine. Okay, so in this one, we obviously need to rationalize it, but before I rationalize it, I like to simplify any surds that I can simplify just to see if it will help. That's what I like to do. You don't have to do that first. You can go ahead and rationalize straight away, but I just think I might as well make my numbers smaller if I can, because it's non-calculator. So what I did, because you can see at the end we're going to end up with some root 2, so all of these I'm assuming are going to simplify to root 2, aren't they, based on that? So what I did was I simplified it. So obviously when you're simplifying a surd, you want to split it into an actual square number, and then obviously whatever's the other factor. And the other one doesn't simplify, fine. This one also simplifies into root 4, root 2. You see they're all going to become root 2s. Then you can actually square root those numbers, right? So that's 3 root 2 plus root 2 squared. And then 2 root 2 minus 2. And then, because they're both root 2s in the denominator, I can add them. That would be 4 root 2, wouldn't it? 4 root 2. Obviously squared. Don't forget to square it. Over 2 root 2 minus 2. Can't subtract the denominator because one's not a surd, right? Yeah, if you were going to do that, you can multiply. If you're going to rationalize it straight away, you can multiply the top and the bottom by root 8 plus 2. That's fine. That's correct. But I would probably do this. Then I would obviously square the top, because why not? Might as well square it. So that's 16. Square them individually times 2, technically, isn't it? Because root 2 times root 2 cancels to become just 2, which is then 32. So I would have done this personally just so that I can get smaller or simplify the numbers a little bit. Now is when I would probably go ahead and rationalize. If you did it the other way around, that's fine. You don't have to do it the way that I've done it. So we need to multiply by the denominator, but you have to change the symbol. So that would become a plus 2 root 2 plus 2. Obviously, same, whatever you do to the top, you have to do the same to the bottom. Now, the top is kind of like single brackets. If you want to write it fully out like that, you can. If you want to just expand it straight away, then that's fine. But it's basically like that, isn't it? And obviously the denominator will always be, in that case, double brackets. But this is like the opposite of difference of two squares. It's like we've already factorized it. We're now going to expand it. How is 16 root 2... 32. Just because I squared it, right? So I squared the 4, got 16, squared the root 2, got 2. 2 times 16 is 32. Yeah. Okay, so now I'm going to expand. Just be careful what is a surd, what is not a surd, and what you can therefore multiply together. 32, you can only multiply it by the 2 on the outside, because the inside is a surd. You can't multiply that by a whole number. And then obviously at the end, that's just a number, isn't it? Just a whole number, 64. Denominator, you can expand it fully, or you can figure out, yeah, this is kind of brutal for 3 marks, to be fair. You can expand it fully, or you can just if you know that it's going to cancel the middle bits, you can just expand the two terms that will stay there, but I'll show you the whole thing just so that you can see. So 2 root 2 times 2 root 2 is obviously 2 times 2 is 4, root 2 times root 2 is 2, cancels out to become 2. And then 2 times 2 root 2 is 4 root 2 plus, don't forget that if there's any negatives, we've then got minus 4 root 2. The whole point is that those will obviously cancel each other out. And then at the end, don't forget that the one at the end will always be a negative, so that's minus 4. Do you see how the ones in the middle cancel? And obviously all the other surds have cancelled because you've multiplied them by surds. Hang on, let me come back. Why did I change the minus 2 to plus 2 when rationalising? You just have to do that, basically, because, so that this bit here, the original denominator had a negative 2, didn't it? Now I've multiplied by positive 2. The reason being, if you think about difference of two squares, like how that works when you expand it, you know how the middle bits cancel? This bit here, this is the reason. Because when I rationalise, I obviously don't want any surds in the denominator. Now if I multiply root 2 by itself, it will cancel anyway. 2 times 2 at the end is obviously a whole number. So that, see how that becomes a whole number? This becomes a whole number anyway. But I don't want any surds left over, so if I change the symbols, I get plus 4 root 2 minus 4 root 2, so they just cancel, becomes 0. So there are no more surds. That's why you have to change the symbol. So if the symbol was originally a plus in your denominator, you'd make it a minus, okay? Hopefully that answers your question. Okay, right, so what have we got now? 64 root, there's nothing to really simplify so far in the numerator, so I'll leave that. In the denominator, we've got 4 times 2 is 8, minus 4, so that becomes 4. Now, do you see how I can obviously just look at it, now that it's rationalised, I can just look at it as a fraction. Of my 3 terms, ignore the surd, because there's only one surd there, but the actual whole number is 64, 64, and 4. If they're all divisible by the same number, same factor, you can divide it. In this case, obviously 64 does divide by 4, so that would be 16 root 2 plus 16. So my last thing is that I always come back and double check what was the format of my answer. What did they want it to be written as? They've got it factorized, haven't they? So I'm going to factorize it. So they've obviously pulled out the 16, and I'll just swap the other way around because they wrote it the other way around, didn't they? Let me zoom out. Can you see? Let me zoom out a bit so you can see. Can you see that? The format that they put it in, I just swapped them the other way around because they did. So yeah, that should be your answer, right? In this format here, 16 on the outside, brackets 1 plus root 2. I think they'd be okay if you put root 2 plus 1. I think they'd be okay with that, but technically they've put the root 2 seconds, so that's what I did. All right, so yeah, I think that should be more than 3 marks, but anyway. As long as you got to that same answer, then that's fine. Okay, we have got 2 more questions, I think. 2 pretty hard questions, actually. This vectors one, it's kind of long. I mean, this is a 5 marker, obviously. If you know what to do, it's not so bad. But I feel like if I just looked at this and hadn't seen a method before, I'd probably have no idea what I was doing. So there's a specific method, and I have seen Edexcel has repeated this question a lot. Obviously, a different shape, different kind of circumstances, but it said work out a ratio or work out the scale factor k. It's always the same question. So at least in that sense, if you wanted to, you could memorize the method and apply it, or you could just go, do you know what, vectors? I don't get it, so I'm going to skip it. That's fine. So we've got OAB as a triangle, OPM and APN are straight lines. M is the midpoint of AB, midpoint here. So we've got O to A is A, O to B is B. Okay, label that. They've given us a ratio. I'm going to write it here, but just so you know, that's not a vector, right? That's just a ratio. That's just a scale. It's not a vector. Work out the ratio ON to NB, ON to NB. So normally, this one's a little bit harder, but normally you have to find 2 vectors from a line that normally crosses through the one that you actually want. So we want the ONB line. Now I know nothing technically carries on through it, but the one I mean is APN. So any 2 vectors from the APN line, You could choose AN, you could choose AP, you could choose PN, you could choose the other direction. Any two vectors from that line, because it kind of, technically, if it were to carry on, it would cross through, wouldn't it? So I normally do AN or the whole line, because normally the whole line is easier, isn't it? So I would go down here, so that's minus A. Now, the only thing is that to go from O to N, I don't have the scale. So I'm going to just add a scale myself. Okay, I'm going to put in a letter. I'm going to put K. It's obviously some smaller version of B, isn't it? So I'm going to put K. So that's AN. That's one thing. You probably get a mark for just writing that. Then I'm going to work out A to P. That's just my preference. I like to work out from the same starting point. So A to P, I would go down again, I would do minus A, but then I would have to come from O to P, so that's when there's other vectors I need to work out, isn't there? This is where you get quite a lot of the marks, is just from writing down different random vectors. So if you're not sure how to work out a vectors question, just write down any vectors you can figure out, and you'll probably get half the marks just for that. So I need to know the whole line OM, which, if you keep backtracking, I need to find AB, don't I? Normally have to find AB. AB is minus A plus B, there's normally always one that's something like that, isn't there? So then O to M, because M was the midpoint, is half of that, isn't it? Just half. Half of that plus the other A. So up here, down there. Okay. So I'm going to expand and simplify that. So I get minus a half A plus A. What's that? Half A plus a half B. Okay. Isn't OB A because OA is A and they're parallel? OB, where's OB? But they're not parallel though. If they haven't told you they're parallel, you can't assume they're parallel. Okay? Don't ever assume. I know I've drawn arrows. I've not drawn arrows because they're parallel. I've drawn arrows because they're vectors, if that's what was confusing. So O to M, and then I only want O to P, which is now using that vector, that ratio, isn't it? Convert the ratio into a fraction, so that's 3/5 of that whole line. Half A plus half B. And I'm just going to, again, expand and simplify everything if you can. You see we've got some fractions again. Plus, oh, put it on. 3/10 B. Okay, so back to AP. A to P. A down here, minus A plus OP plus 3/10. It's just long. I just think, sometimes I think it's not worth the time, because even when you know what you're doing, you still take longer than 5 minutes. Okay, so now I'm going to actually, obviously make sure you collect the like terms, right? So I'm going to add them. That's technically a -1, isn't it? -1 plus 3/10 is -7/10. A plus 3/10 B. Make sure you've got A and B in the correct order, because now is where we're going to create some simultaneous equations. This is normally the bit that throws everyone, so if you don't get it, I probably wouldn't worry for tomorrow, honestly. Coefficient of A with the coefficient of A here. Now, I can't put them equal. They're not equal to each other, because think about it. AN as a whole is bigger than AP, isn't it? So I actually have to bring in another scale. The scale is for the APN line. Now, I don't really care what that scale is. I just technically have to put it. And I normally just multiply it to the side that's easier. You multiply it to whichever side you want. So this is technically -1. I'm going to write it fully, like multiply. This is my scale for APN, right? I know this is where it gets really confusing. That's one of them. That's the A coefficients as an equation. Then do the B coefficients. Do you see how, because I want to obviously have K, that's the one I actually am interested in, isn't it? Now multiply the same side by the same scale, so that would be Kx is 3/10. Do you see how I've got simultaneous equations? I know this is kind of wild. Like, if this doesn't make sense, I honestly would probably just go as far as AP and then stop. I wouldn't even waste your time. Yeah, I would decide, you might just decide to skip it. It depends what's worth your time in the exam. If you're going to spend 20 minutes on this question, then it's not worth it. It's honestly not worth it. Just write down any random vectors you can figure out and move on, is my best kind of advice for vectors. So now I've got this, I'm going to solve it. Obviously, let me rewrite this. That's just -x, isn't it? I was just trying to show you where I got the -x from. That's just -x. Solve it. Now in this case, we actually can work out x. We don't need to, but we, as in, normally I don't really care what x is, but technically in this particular example, it does gives it to me, doesn't it? So the AP line, the scale was 7/10. Anyway, I'm obviously going to sub that in because the actual one I want to know is K, isn't it? That's the one I actually want to know. So that's 7/10 K is equal to 3/10. Now I've just got fractions, divide, keep flip change. I'm just kind of running through this because I know it's quite late. Do you see how the 10s would cancel? So K is 3/7. That's my scale for the line that I actually want. The only thing that's left is that they did ask me to leave it as a ratio. Okay, so I need to convert my fraction into a ratio. Now remember, originally, I used ON, didn't I? ON. So when I'm saying this K bit here, that was the ON bit. So what I'm saying is that, this is 3/7 of the line, OB, and then this is obviously therefore 4/7, isn't it? It has to add up to 7ths. Okay, so then the ratio is just 3/4. Just think, how do I convert from a ratio into a fraction? Just do the opposite, okay? I know it's so long that it's actually, I don't think it's worth it. Even if you know what you're doing, do you see how long that still took me to get through it? So, let me just check for questions. Yeah, I would say this is one of the hardest vector questions, but they do repeat it a lot, which is bad in the sense that it does come up a lot, but good in the sense that it is a repeated question. You can memorize the answer, or you just decide, you know what, I'm not even going to bother, which is fine. Yeah, I don't know who said vectors were easy. Maybe they were referring to the column vectors, because that is easy. But this type of vectors, I don't think so. I mean, vectors, if it says prove that these two vectors are parallel, prove they lie on a straight line, that is quite, that's relatively easy if you can, again, just memorize kind of the method. That's fairly easy. This one where they've asked for a ratio or they asked for a scale, not great. Not great, honestly. Not great. Okay. So yeah, I don't think I'm going to spend much more time kind of explaining that. I've got videos on it. If you want to go through more videos, check out my channel. There are videos on it. There's videos in terms of vectors, ratio, and scale. There's videos in terms of the hardest vector questions, which is obviously this type of question, that type of thing. I mean, for tomorrow, I wouldn't worry. If it doesn't come up tomorrow, then you might be able to learn it for next time. But I honestly would not worry. Okay, we're on our final question now. I've actually been through this question, I think, in another video. So you can always look at that. I think it was in the hardest probability questions for Edexcel. It's in that video. This is basically just algebra, though, to be honest. It's not super hard if you're happy with algebra. Yeah, if you're really happy with algebra and you can set up the equation from there, it's fine. But it's quite long, I guess. So obviously also another, this is actually 6 marks, this one, not even 5 marks, this is 6 marks. So last question. Okay, there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in a box. When I see something like that, in my head I'm thinking I'm going to bring in some algebra here. That's just me like translating it, if you know what I mean. Not from words, not into words, but into actual algebra. And then they just happen to say that there are more than 12 pens in a box. Fine. What I normally do is I just say the smaller one is x, so green would be x, blue would therefore be x plus, you can use whatever letter you want, x plus 3, and then the total in the box is therefore 2x. Can you see that? Yeah, just about. And then we know that that's bigger than 12. So you could write those kind of facts there. Let me bring it down a bit. Okay, Simon is going to take at random 2 pens from the box. This is telling me it's like the concept is probability trees. You don't have to draw a tree if you're happy to kind of work it out without visualizing it. I just like to visualize it, so I will draw a tree. But that's a tree, isn't it? The probability that Simon will take 2 pens of the same color is 27/55. Work out the number of green pens. The reason why I've chosen to use x and then x plus 3 instead of using 2 different letters like G for green and B for blue is because there's only enough information for one equation. This is the line here. If I've only got enough information for one equation, then I can only have one letter. Okay? So that's why I've chosen x and x plus 3. So basically, I'm just going to visualize it, like kind of draw it out for you. But as I said, you don't have to draw it out if you can visualize it in your head. So the first pen, green. The probability is x out of 2x plus 3, isn't it? There are x green pens, and then it's out of the whole box, which is 2x plus 3. Blue is x plus 3 out of the same denominator, obviously, and technically those would add up to 1, wouldn't it? Now, the second pen, you can fill out the whole tree. I'm actually only going to fill out part of the tree because you see how they've said the same colour? So I'm only going to kind of draw green and green and then blue and blue because I can't really be bothered to draw the rest and you don't need it. So the probability of getting another green. Now, this is the bit where it's a bit, I don't know, this is a bit harder. If Simon is going to take two pens at random, he might just grab 2 at the same time. He's not replacing them, is he? This is not a replacement situation. How is it 3 plus x? Because more translates to plus. It's not 3 times as many pens, it's 3 more pens. So the amount of green plus another 3. 3 more. Yeah, this is a 6. I know, this is quite surprising. So, because they're not replacing it, it hasn't said that he's going to replace the first pen. So my assumption is, if he takes 1 green pen, there's then 1 fewer or 1 less green pen in the box. But also, there's 1 fewer, 1 less pen in the box overall. So your second fraction has to be different because there's no replacement. He doesn't replace. Where did I get 2x from? Here, the total, if green is x and blue is x plus 3, if I add that together, do you see how I get 2x plus 3? For the total in the box. I just added those together. Now obviously this one, again, if I've picked blue already, I've got 1 less blue pen, so x plus 2. If I've picked 1 pen already generally, there's 1 less pen generally. Okay, so that's my tree. Then, what I need to do is, okay, how do probability trees work? Where you always multiply between the branches, don't you? Always. So the probability of getting both green and green is, and this is where I'm going to start building my equation, right? X over 2x plus 3 multiplied by x minus 1 over 2x plus 2, okay? And then, so that's the green ones, isn't it? That's the green and green, but I could also get blue and blue, couldn't I? That would satisfy the question. That would satisfy getting 2 pens of the same colour. So write that out, multiply it. And then if you think about probability trees, again, this is why I drew it out, so I knew kind of how the tree works. If you have multiple, options at the end, I have green and green or blue and blue, you add them, don't you? You always add the different options if there are more than one option. In this case, there's 2 options. So I add them. Now this, all of this is what is equal, can't really see that there, but is equal to 27 over 55. Now, as I said, you could have built that equation without drawing the tree if you wanted to. If you can kind of visualize it in your head, fine. You don't need to draw the tree. I just like to draw it so I know what I'm doing. Now, all I need to do, the last bit, I say the last bit, obviously, most of the marks, is just solve this. Basically, I just need to solve all of this. So now we're just forgetting about the context, just think about it as solving it. So I probably multiply these first, I guess. X squared minus x. I would expand everything because we're going to try and solve it. You get 4x squared, you get plus 4x plus 6x, so that's plus 10x plus 6 for the first one. Luckily, they obviously both have the same denominator, don't they? X squared plus 5x plus 6. I'm just expanding brackets here, right? Same denominator. Because they have the same denominator, I can just add the numerators as well in the next step, can't I? So that's fine. Add the numerators, so we get 2x squared plus 4x plus 6. 4x squared plus 10x plus 6. Okay. You've got 2 options here. You can obviously cross multiply, as we mentioned before, as in multiply by 55, multiply by that denominator. What I actually did was, looking at the left-hand side, you see how all 6 terms are multiples of 2? 2, 4, 6, 4, 10, 6. They're all multiples of 2. So because, and this is kind of just saving myself because it's a non-calculator paper, I chose to kind of divide it all by 2 just to make the numbers smaller. Do you know what I mean? Just so that then when I multiply by 55, it's not as bad. And by 27, it's not as bad. So that would become x squared plus, that's just on the left-hand side, just simplifying the fraction. You don't have to do that. I just wanted to because I didn't want to deal with bigger numbers. So now I would cross multiply, okay? And you know what I mean by that. Just multiply by both denominators. I would do it in one step. You can do it in 2 separate steps if you want. I would just do it in one step. Don't know why they only gave you like 1 page, not even 1 page of space really. So you do have to multiply by 55, but I would just kind of add up the multiples. Obviously 55x squared, double that is 110x, and then add another 55, 165. It's not great, but I don't think you can simplify that fraction anyway. So I didn't divide the other side by 2 because I wasn't moving anything. Like I wasn't moving the 2 across, it just naturally cancelled itself out. So it's different than when you're applying something like, I wasn't trying to move the 2 from one side to the other. It just naturally cancelled itself out. Well, the thing is, this question is the final question, so I'm assuming you probably would have attempted at least all the other questions before you hit this one anyway. But yeah, if you do get like a 5 marker kind of in maybe 2/3 of the way through and you feel like you're not sure, I would always recommend just anything you're not sure about, maybe just keep going. Just skip it, keep going, come back later. Because I would rather you actually at least got to see all of the questions than got stuck on one of them and didn't end up seeing the ones at the end. So just keep moving. You can always come back. Okay, what was I doing? Yep, times that by 27. So 27 times 2 is 54, I think. 54 times by 5. The way I times by 5 is I just times by 10 and then half it. So 270 divided by 2 is 135. That's how I do it. And then times by 3 is just the same as 3 cubed. Well, no, 3 to the power 4, isn't it? Which is 81. Okay, now because I'm going to end up with a quadratic overall, what I'm going to do is move either from the left to the right, right to the left. I need to get something on one, like all of my terms on one side to make a quadratic, and then equal 0. The way that I decide which way round to move them is I want to have x squared as positive. So what I'm going to do is move all of, in this case, the right to the left. So if I take away 54x squared, you see how I still have positive x squared. You just move it to whichever side you want, but I'd rather keep the x squared positive. So minus 135 is minus 25x, and then minus the 81 is plus 84. Now I've got a quadratic. I can't simplify it any further, so I'm going to try and solve it. Because the context was pens, I'm assuming it's obviously whole numbers, so I'm going to factorize. So x, I know the numbers are still quite big, but it's not great. They're both negative, aren't they? Factors of 84 that add up to make 25 would be 4 and 21, I think. So then we get 2 answers. Obviously, because we got 2 answers, I do need to go back. We're almost at the last bit. I do need to go back and just choose one of these based on the context, right? So 4 and 21, keep that in your mind. Let's go back to the start. What piece of information have we not used yet? The piece of information we have not used is this. There are more than 12 pens in the box, so that's how I'm going to decide which one to use. So remember that x, in my case, x represented the green, didn't it? So x and then x plus 2. So just sub them both into your total. Which one gets you a bigger number than 12? If I sub in 4, I would get 11. That's not big enough. Okay? So clearly I'd have to use 21, wouldn't I? Do you see how because I've got a context, I need to decide? So the final answer, after all of that, is 21. You do have to choose. You can't just leave both, you have to choose. Okay. So that's 21. I have got this question differently if you need more explanation. But otherwise, yeah, that is the whole paper. So hopefully it's not harder than that because that was a November paper. Otherwise, if you don't have any other questions, guys, I think we should leave it here. It's quite late now, so I obviously want you to be able to rest before you've got your exam tomorrow, because it's in the morning, isn't it? Tomorrow morning. I really hope it goes well for you guys. Best of luck. Please don't stress if you feel like it's not going well. Don't worry about it. It's only 1 out of 3 papers, okay? So just keep, the main thing is to just keep calm, okay? Just keep calm and just write as much as you can. Write down anything, even if you don't know how to answer the question, just write down anything you think is relevant to the question. So if it mentions area, maybe write down a formula for it. Do you know what I mean? Like if you're not sure what to do, just write down something. Please, just my best advice is try not to leave anything blank if you can avoid it. Even if you think you're writing something completely irrelevant, just write it down anyway, because you just never know where the marks are going to come from. So write down as much as you can, even if you're not sure. If you don't understand a question, skip it, move on, keep moving, keep pacing through that paper, come back at the end if you need to. Okay, that's my those are my bits of advice. Don't get overwhelmed, don't stress about it, it's not the end of the world. If it doesn't go well, you've still got 2/3 of your exam paper, like mark left after this. So please don't stress, don't like lose your head if you're in the middle of the exam and you're not sure what to do. It will be fine, I promise you, it will be fine. Okay, so that's my advice. Best of luck, guys. I'm going to leave it here so that you guys can go and get some rest for tomorrow, and we'll catch up next week, okay? Thanks for joining me, thanks for interacting, and yeah, best of luck for tomorrow.